Welcome to Module 7 of Political Statistics. In the last module, we explored linear regression. We covered how OLS works on a conceptual level, learned how to interpret coefficients and the intercept, looked at the limitations of regression modeling, and applied it to the case of global infant mortality. In that lesson, we brought together everything we've learned so far and discussed the tool that, if you choose to pursue the social sciences further into graduate school, will be your workhorse. In this module, and in the next, we'll apply everything we've learned to get a better sense of how these tools are used in practical situations. In this module, we'll approach a problem from an academic perspective. We'll focus on theory, soak and poke around in a dataset, and identify possible research questions. In the next module, we'll approach a problem from a non-academic perspective. We might call it a practitioner's perspective, where building knowledge is less important than achieving a given outcome. Together, these two modules should give you a good sense of how statistics is used and whether you're interested in pursuing a career in academia or in the private sector that uses these tools. Let's get started. In the previous modules, we haven't spent much time talking about the social theories that might help us make sense of the data we've noodled around in. Even though I've repeatedly said that's a bad thing to do, we stuck to simple datasets and kept away from social theory to help highlight the mechanics of the techniques we learned about. Doing things that way helped us focus on the technical aspect of political statistics, but it was devoid of the political aspect of political stats. Today, we're going to noodle with the data, but we'll noodle with a greater sense of direction and with a firmer grounding in the academic literature. This week, we're going to get a taste of what academic research looks like, at least in its early stages. As such, we won't be making any groundbreaking discoveries or implementing anything overly complicated. Instead, I want you to get a taste of what it's like to get familiar with data, how to implement simple tools to understand trends, and how to visualize those trends to get yourself and others oriented within a question and a social context. Before we dive in, there's a few things worth saying. Note that the process we'll work through in this module looks a lot cleaner and easier than it actually is. That's for a few reasons. For one thing, I'm familiar with this topic, so I already know where to look for relevant theories and data. In practice, when you're doing your own soaking and poking, you'll need to take time between finding some interesting trend and taking the next step, because you'll need to go off and read some books and journal articles to help make sense of what you've found. That process takes time. Moreover, I'm probably a little more familiar with the statistical techniques, the R programming language, and with visualization best practices than you are. That's not to diminish your skills, but rather to say that I probably have more of an intuition about what makes a good visualization and what a good metric to calculate might be, for example. So the effort it takes me to go from idea to output is a lot smaller than it will be for you. By this point in the class, you surely have more of an intuition than you did at the beginning, and as you continue in your studies and career, you'll build on that. But for now, the only way to get there is to make mistakes and struggle with stupid, frustrating code. In your final paper, I want to see you take chances with strange, goofy-ass visualizations. As long as your basics are solid, take the time to try things out and to fail. You'll be surprised at how quickly you gained that intuition. With that, let's dive in. As a student, you're likely paying a whole lot of money in tuition, fees, and for books, and I suspect you're not doing that so you can drop out in 8 years without a degree. You want a degree, and you want the money that comes with that credential. In today's example, we're going to look at outcome metrics for students at my alma mater, a community college in Illinois called the College of DuPage. Everything we'll do today can just as easily be reproduced for whatever college you're attending, likely Arizona State. And if you're interested in the topic, I encourage you to do so. So let's start where all good research starts: Google. According to the great scholar Google, about 22% of full-time students at COD graduate. That seems low, but alone, this number doesn't tell us much. So let's try to find the source of this data and see if we can find the original dataset that was used to produce this number. A few clicks and some Googling later, and I end up at the website for the Integrated Post-Secondary Education Data System website, or IPEDS. On the IPEDS website, there's a tab for Data and Tools, and an option to download microdata, then an option to look up specific schools. So let's go ahead and do that. And look at that. On the very first tab that we land on, there are all sorts of summary statistics. Terrific. Let's see if we can find graduation rates. Okay, so it looks like the number we found on Google was the 3-year graduation rate for the cohort starting in 2017. There are some other interesting statistics here too. More women graduated than men within 3 years. Here, they refer to that as 150% of completion time. There's a lot of variance between racial and ethnic groups, and Pell-eligible students are a lot less likely to graduate than their non-Pell-eligible counterparts. Those are some interesting tidbits and might be worth digging into. So let's try and find the raw numbers that produced these statistics. On a different tab labeled Reported Data, we find what we're looking for. Lucky for us, the data goes back about 10 years. So now comes the fun part. I'll have to get this data into a form that I can use in R. Since it's not too much work to do so, I'll just copy and paste the fields I'm interested in into an Excel file, the total size of each subgroup, and the number of students in that subgroup that graduated within 3 years. Okay, so I wouldn't call that fun, but it only took me a few minutes to do all of that copying and pasting. Let's see what we've got, so we know what problems to anticipate once we open this up in R. Well, first off, the column names have spaces in them, and I'm almost certain that'll cause problems. So let's get ahead of that and change those names before we pull this into R. Next, it seems that we have some zeros that are shown as blanks. I want to make sure R reads those as zeros. It seems like there are also rows that give us within variable totals. That might be handy if we weren't adept at manipulating data, but since we are, those rows will probably just get in the way when we're trying to do things like sum values within a group, so we'll drop those rows in R. So at the end of the day, I want a column for ethnicity, gender, year, the variable, meaning a categorical column that tells us counts of completion, transfer, and not enrolled, and one for the number of students in those categories. That way, we can easily answer questions like, in 2013, how many Hispanic or Latina women graduated from the College of DuPage? Great, so our noodling is complete and data is in R. Why don't we start simple with counting? We already know that different groups of students have different probabilities of completing a degree, but to ground ourselves in COD's particular circumstances, it would be helpful to know what its incoming cohorts look like. So why don't we see how gender and racial ethnic demographics have changed over time at COD? Let's start with gender. I think I want to start with raw counts. So why don't we try a line chart and a dodged bar chart? Meaning 2 bars for each year that are right next to each other. One for male identifying students, one for female identifying students. It seems that COD consistently has more male than female students. That's interesting, given that we know more women finish degrees thanks to that summary stats page. Let's put that on our list of things to search the literature for once we've finished here. Next, why don't we do the same, but for race and ethnicity? And since our line chart was so helpful, let's try doing that again. Okay, so not quite as helpful here, though some things do stand out. In particular, that incoming Hispanic or Latinx students have increased in total number by quite a lot. But there are too many groups for this line chart to be really useful, so most small groups get all squished at the bottom. I also don't get a good sense for how the size of total incoming cohorts has changed over time. I don't think a dodged bar chart is going to fix that, but maybe a stacked bar chart will. Instead of putting all the little sections next to each other, We should just put them on top of each other. That way, we'll get a better sense of how big each class was. So let's go ahead and do that. All right, ups and downs, but relatively stable. This data stops at 2020, so incoming cohort year 2017, which is probably not why we're seeing a giant COVID drop. And since we're here, why don't we see what the average incoming cohort size is and how it deviates from year to year. Average class is of about 2,300 students, and a standard deviation is about 300. These are definitely sizable cohorts. My alma mater is not a small college, it would seem. Now that we're situated, why don't we get back to what brought us to this data in the first place, exploring differences in the rates of outcomes. We know from the summary statistics page that students who identify with different racial ethnic groups have different probabilities of graduation. So why don't we start simple and look at graduation rates and get situated? We'll have to do some pivoting and calculations, but once we do, let's plot it in a line chart. That way we can see how graduation rates have changed over time. And given that we know there are a few racial ethnic groups with very few students, let's just stick to the top 4 by population. That is, students identifying as Black or African American, white, Asian, or Hispanic/Latinx. And that makes me very sad. Not only is the gap big, 15 percentage points between Black or African American identifying students and white students in 2020, but it is persistent. There are clear patterns of stratification here. So what we saw on the summary stats page of the iPed's website wasn't a one-off or some aberration for that particular year. At this point, we should probably take off our data analyst hats and put on our political scientist hats and consult the literature, because we're getting to a point where we're likely to mistakenly imply causes for what we're observing without understanding why. So let's do that. And here's a hint for when you're trying to get situated in a field. Most disciplines have a journal that's exclusively for reviewing the state of the literature. In fact, pretty much all such journals are published under the Annual Reviews title, which has its own website that you can easily search. These journals publish articles that are basically just gigantic literature reviews on a topic. If we look up our finding, we find pretty much exactly what we're looking for right away. An article titled Racial and Ethnic Stratification in Educational Achievement and Attainment. I'd also suggest Why Race and Culture Matters in Schools by Tyrone Howard and James Banks. But that first title is a little old, written in 2003, so why don't we use Google Scholar to look up other pieces that have cited it and that are more recent. We probably won't find another comprehensive review article, but that's fine. The core theoretical approaches usually don't change that much over 10 or 20 years. Let's also put, quote, The Determinants of University Dropout, a review of the socioeconomic literature, unquote, in our to-read pile. And after reading those books and articles, we might find a few different types of explanations for what we're observing. First, some explanations emphasize a student's class origin. That is, if you grew up poor, you're likely to stay poor. Colleges don't really change that. And it's not just the financial aspect of class that matters. Cultural symbols matter too. That is, middle and upper class folks have certain patterns of speech, habits, networks, and behaviors that are essentially irrelevant to meritocratic education, but that society values quite highly because they signify you are from the middle or upper class. For example, someone who spent their summers at sleepaway camp has different cultural assets and touch points than someone who spent their summers at the Y. Colleges and other institutions systematically prefer the former type of students more than the latter. That might not be because an admissions counselor is explicitly classist, but at the structural level, these preferences become clear. For class-based explanations, other factors might matter, but class predominates. See, quote, Schooling in Capitalist America by Bowles and Gintis, unquote, and Ain't No Making It by MacLeod for these types of explanations. Second, we might find economic explanations. These explanations assume that students are rationally calculating individuals who complete degrees if they calculate that doing so will have a bigger payoff than the wages they're giving up now. After all, you could be working and earning proper money instead of going to college. Your time has money value, and economic explanations assume that you are well aware of and act on that fact. For these explanations, class structures matter, but the decision is ultimately made at the individual level. Third, we might find race-based explanations. These are still structural in the same way that class-based explanations are, but they instead point out that race has been quite important in the history of American institutions as a driver of outcomes. Most scholars working in this theoretical vein usually don't argue that stratified outcomes, like the ones we've observed, come about because individuals are being mean. Rather, they point out that all throughout the higher education system, benefits accrue primarily to non-Black and brown people due to policy choices and the remnants of segregation. Moreover, they point out that educational segregation never really ended. Jonathan Kozol in Shame of the Nation and Carol Corbett Burris in On the Same Track show how school segregation has in fact gotten worse since the 1980s to a pretty alarming degree. There are other types of explanations, but these three cover the basics. So let's take those broad theoretical approaches, think about them, and get back to our data. In fact, why don't we think about those theories and explicitly write down some of the hypotheses they imply? If we have the data to explore those hypotheses, we will. And if not, we'll put them on our list of open research questions. First, class-based explanations. Unfortunately, the only way we might measure class is through income, and an okay proxy for that might be Pell-eligibility. But IPEDS doesn't have any data on how people within each racial ethnic group are Pell-eligible or not. So we probably can't run any sophisticated linear regressions on that sort of data. Then again, it might be helpful to see what the gap between Pell-eligible and non-eligible students is like over time. Next, economic explanations. Again, Pell eligibility is probably the best proxy we have for a student's financial position. But note that we're already having that one variable do a lot of heavy conceptual lifting. Let's plot it, but give some more thought to what types of measures we might use to better capture economic incentives. Finally, with race-based explanations, we might want to see how those graduation rates change over time. And in fact, linear regression might be really useful here. It'd be helpful to know what an intercept and coefficient are for our lines over time, and if, as graduation rates change for one demographic, if they also change for another, and if so, in one direction. We won't interpret these causally, but it'd be an interesting way to summarize the covariance. First, our Pell charts. The first thing to note is that IPEDS only has data on Pell eligibility and completions through 2016, so we're working with an even more limited time frame here. Even so, let's see what we get. What's the difference in completion rates between Pell-eligible students and non-eligible students? Big, but not as big as some of the gaps between racial ethnic groups. In fact, why don't we calculate the difference between these two lines and plot that instead? So that instead of looking at raw completion numbers, we can see how big the gap between Pell-eligible and non-Pell-eligible students is. At its biggest, the gap between Pell-eligible and non-eligible students was about 8%. That means even if we assume the worst case scenario, that all of COD's Black or African American students are Pell eligible and that all of its white students aren't, we still couldn't explain why that gap is so big. And to be clear, there's no reason for us to make that assumption in the first place. So let's put that on our list of open research questions. How do race and class, or at least financial need, overlap? Let's recall our other theoretical foundations, that economic issues are primarily at play and that de facto segregation pretty much never ended. We've partially looked into the first, and looking at iPads, there is some data about the financial distribution of students' families. That might be helpful to understand the distribution of COD's financial demographics, but that data isn't combined with outcome metrics, so we'll have to put that on our list of open questions. And we might formulate it in this way. How does the distribution of financial opportunity differ between COD and other community colleges? Which leaves us with questions about policy and race. Now, it feels like we haven't quite used the race-ethnicity data to its fullest extent, so why don't we apply some of the more complex tools we used to see if we can understand the data a bit better. One theoretical expectation of race-based explanations is that minoritized students will likely start from a disadvantaged position and benefit from overall improvements less than their counterparts. One way we might explore that implication is by fitting a linear regression within each racial ethnic category. We'd find the coefficient of the trend line that best fits each group's progress over the last 10-ish years and the intercept of that model. Before we do that, why don't we subtract our minimum year, 2011, from all of our years? That way, our first year is 0, and we can interpret the intercept of the resulting regression as the starting completion rate. Once we do that, let's plot the intercept and coefficient for each linear model, along with bands for the standard error of each of those estimates. Our theoretical expectations are roughly correct. For one thing, we definitely see that Black and Hispanic students started with lower completion rates than their Asian and white counterparts, given the extent of our data. That's the intercept part of our chart. Moreover, we see that with each year, their completion rate tends to increase at a slower rate than their white counterparts. Why might that be? Again, we have our theory, and our data isn't sufficient to be making causal claims. So what might be driving this observation? Well, we know from Ain't No Making It and economic explanations that students set their aspirations according to what they perceive they're likely to gain from education. It might be that COD's Black students perceive that the benefits of an associate's degree are lower for them than they are for their white or Asian counterparts. And if we dig into the literature again, we find out that turns out to be true. The benefits of a high school diploma, college degree, and professional or graduate degree differ by race and ethnicity. In a sense, what we're observing here might be that minoritized students, including Pell-eligible ones, by the way, not just racial ethnic groups, are making an economically savvy decision about their chances on an unfair labor market. Of course, we'd want to dig more into these colleges' specific case to find that out, but given what we've learned from the literature theory in our data, that explanation seems like it's worth digging more into. Before this exploration gets too long and tedious, why don't we start wrapping up? First off, we did quite a lot of exploration with this admittedly small data set. We looked at counts across demographic groups, outcomes across demographic groups, we fit linear models to trends over time, interpreted those linear models, and did all of the above in the context of some social theories. Of course, there are plenty of other analytical tasks that we could have undertaken. Instead of raw counts, we could have looked at percentages and how cohorts change over time. We could have compared the changes in completion rates between groups and fit linear models to those changes to see whether, as one group benefits, others also benefit, or if benefits for one group come at the expense of another. We could also have expanded our analysis to some subset of community colleges and seen how COD compares to them. Ultimately, the point of this analysis wasn't to produce an exhaustive explanation of every possible trend we could find, or to apply every single theoretical lens to our interpretation. Instead, it was to give you a feel for what the beginning stages of social analysis using statistics looks like, how to pick tools for that analysis, and how to ground that analysis in social theory. That's really all I'm looking for in your final papers. Some sense that you collected or found a dataset, that you explored a few different avenues, that you understand a theory that helps you make sense of the patterns you find, and that you can present those patterns in a compelling visual manner. Next time, we'll take on the role of a campaign manager and see if we can craft a strategy to win an election. I'm looking forward to seeing you in our final module.